Sir, good evening.
Pascal theorem. Pascal theorem. Most important compulsory question can Pascal theorem. So concepts. Concepts. Definition. 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 Definition.
Sir, hello. Hello.
చెప్పండి.
Sir, ఇది పేజీ నెంబర్ థీరం చెప్తారు.
For 79. Page number
ఓకే.
70.
అంటే డైరెక్ట్ గా మీరు ఇప్పుడు చెప్పే థీరమేనా సార్? ఇది ఆస్కాలి థీరం డైరెక్ట్ గా.
కాన్సెప్ట్స్ చెప్పి దాని ముందు థీరం ఉంటుంది, దాని తర్వాత పాస్కల్ థీరం చెప్తారు.
సార్ చిన్న రిక్వెస్ట్ సార్. హలో సార్. హలో.
చెప్పండి, నాకు వినబడుతుంది.
ఓకే సార్. నిన్న నాకు సిగ్నల్ ప్రాబ్లం వల్ల మీకు టోపాలజీ క్లాస్ వెళ్ళలేదు సార్.
ఓకే.
ఏమన్నా ఉంటే నోట్స్ ఏమన్నా కొంచెం పంపిస్తారా సార్? గ్రూప్ లో పెడతారా?
యూట్యూబ్ లో అప్లోడ్ చేస్తారు, అవి చూసుకోవచ్చు మీరు. మన
అవునా సార్? అంటే నేను యూట్యూబ్ లో చూస్తే లేదు సార్ ఇవాళ.
ఇప్పుడు అప్లై చేయరు, కొంచెం టైం పడుతుంది. క్లాసెస్ అయిపోయినాక చేస్తారు.
ఆ,
అది మన ఎస్ఎస్బి వాళ్ళని అడిగితే హెల్ప్ లైన్ నంబర్స్ వాళ్ళు చెప్తారు
ఆ.
ఎప్పుడు అప్లోడ్ చేసేది ఏంటిది అనేది. అది మాకు తెలియదు అనమాట. కంప్యూటర్ సెక్షన్ వేరు, ఓన్లీ మాది టీచింగ్.
ఓకే సార్. ఓకే.
మీ గ్రూప్ ఉంది కదా, ఎంఎస్సి ఫస్ట్ ఇయర్ది. ఆ గ్రూప్లో ఎవరైనా రిక్వెస్ట్ చేస్తే మీకు నోట్స్ పంపిస్తారు. మీ గ్రూప్లో యాడ్ అయ్యారా లేదా?
అంటే మేము గ్రూప్ చేసాం కానీ సార్, తలా ఒక దగ్గర ఒక గ్రూప్ ఉంది సార్ ఇక్కడ.
యూనివర్సిటీయే పర్సనల్గా గ్రూప్ చేసింది, నేనే చేశాను.
ఎవరు? అఖిలానా సార్?
నేనే. నా పేరు అప్పారావు, డాక్టర్ అప్పారావు.
ఆ.
నేనే క్రియేట్ చేశాను. అందులో మీరు రిక్వెస్ట్ పెడితే ఎవరైనా ప్రీవియస్ నోట్స్ ఇస్తారంటున్నాను. ఆఫ్లైన్
లేదు
క్లాస్.
సార్, BRAOU MSc మ్యాథ్స్ అనేసి ఉంది, అదేనా సార్?
అదే 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 మాది. ఓకే.
ఓకే సార్. ఓకే సార్.
టూ యూనిట్స్ కంప్లీట్ చేయాలి కొంచెం ఫాస్ట్.
ఓకే.
నెట్ ఎక్స్పిఏ, నెట్ ఎక్స్బిఏ మెట్రిక్ స్పేస్. Let x be a metric space with metric D, with metric D. A sequence xn is sequence xn xn is sequence xn in x. A sequence xn in x is called Cauchy's sequence. Is called Cauchy sequence. Cauchy sequence called Cauchy sequence. If D xn to xm, nothing but distance function, xn to xm, m tends to 0, as n comma m tends to infinity for any epsilon greater than 0, greater than 0, there exists a positive n naught. There exists symbol positive n naught. N naught belongs to capital N, set of natural numbers. ST means such that dxn comma xm is less than epsilon for all less than epsilon for all n comma m, for all n comma m greater than or equal to n naught, greater than or equal to n naught. Using this definition, I'll prove using the definition, one theorem will prove. Page number 80. Page number 80. Page number 80. Prove that in any metric space, theorem. Prove that, prove that, prove that in any metric space, in any metric space, any metric space, any metric space, any metric space, every convergent sequence is Cauchy sequence. Every CGT means convergent. Every convergent sequence is a sequence is a every convergent sequence is a Cauchy sequence. Cauchy sequence. Cauchy sequence. Proof. 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 Let Xn be a convergent sequence. Let Xn
నేను రాయి మార్కులు పోతాయి, ఏం సిలబస్ కావట్లేదు, 18 చాప్టర్లు చెప్పేది వాళ్ళు.
let Xn be convergent sequence. Convergent sequence. Convergent sequence. In a metric space X, in a metric space, MS means metric space X, metric space X, T, where X belongs to capital X, such that Xn belongs to X. Xn belongs to X. Xn belongs to X. For all epsilon greater than 0, nothing but definition, epsilon greater than 0, we have epsilon by 2 is greater than 0, and hence there exists integer and hence there exists a integer. There exists integer. There exists a symbol integer n not greater than 0. N not greater than 0. Such that d of xn comma x less than epsilon by 2. Less than epsilon by 2. for all n is greater than or equal to n naught, n equal to greater, and hence and hence and hence dxn comma xn comma x less than or equal to d xn comma xn comma x plus d x comma xn less than epsilon by 2 plus epsilon by 2, that equal to epsilon that equal to epsilon for all n comma n, this is n comma, here m is n comma m, for all n comma m for all n comma m greater than or equal to n naught, thus xn is Cauchy sequence is Cauchy sequence Cauchy sequence Cauchy sequence Cauchy sequence Cauchy sequence Cauchy sequence Cauchy sequence. Next. Next. Definition. Page number 81. Page number 81. Definition. Page number 81. Definition. 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 A metric space is said to be complete. A metric space is definition. A metric space is said to be complete. Theorem is depending upon definition. Okay. So a metric space is said to be complete. A metric space is said to be complete. A metric space is said to be complete if every Cauchy sequence every Cauchy sequence a metric space is said to be complete if every Cauchy sequence converges. CGS means converges in it. It is well-known result in analysis. It is well-known result in analysis. Well-known result in analysis. Real system R with usual matrix is complete metric space. With the usual metric is a complete metric space. Is a usual result is a complete metric, complete metric, metric, metric space, complete metric space. Okay. So in the complex number system, R power n for any positive integer n with the Euclidean matrix space. So using this definition, we'll prove one theorem that is for 10 marks. Theorem. Prove that means question formation is prove that or show that a subspace of Y, a subspace of Y, subspace of Y, a subspace of Y of a complete metric space X, of a complete metric space of Y, complete metric space of Y, complete metric space of a submetric space of Y, complete metric space of X, metric space of X is complete, is complete if and only if the symbol is known as if and only if Y is closed in X, if and only if is closed in X, Y is closed in X. Proof. 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 So, suppose Y is complete. Let Y is complete. Y is complete. If small x belongs to Y bar, small x belongs to Y bar, then there is a sequence Yn, then there is sequence,
And
then there is a sequence Yn, then there is a sequence, is a Cauchy sequence, is a Cauchy sequence, is a Cauchy sequence, is a Cauchy sequence, a Cauchy. Yn is convergent in Y, then the sequence Yn is CGT, means convergent, CGT in Y, and hence there exists a, and hence there exists small y belongs to capital Y, small y belongs to capital Y, such that, S means such that Yn tends to Y, Yn tends to Y. Then x equal to Y belongs to, then x equal to Y belongs to capital Y, capital Y. Thus Y bar equal to Y, thus closure of Y bar equal to Y, and Y is closed, and Y is closed, then Y is closed. So conversely, suppose that Y is closed. Conversely, suppose that, Y is closed. Conversely, suppose that Y is closed. To prove that Y is, to prove Y is complete. Y is complete. Y is complete. Let Yn be a Cauchy sequence. Let Yn be a Cauchy sequence. Cauchy sequence. Let Yn be a Cauchy sequence. Let Yn be a Cauchy sequence. Cauchy sequence in Y and hence in Y and hence and hence and hence in X and X and X. Since X is complete, there exists. Since X is complete, X is complete, X is complete, there exists small x belongs to capital X. There exists small x belongs to capital X such that Yn tends to X. Yn tends to X. Tends here. But X belongs to Y. Closure of Y. Closure of Y. Closure of Y. That equal to Y. Equal. And hence Yn is convergent in Y. And hence Yn is CGT means convergent in Y. Thus Y is complete. Thus Y is complete. This completes the proof, hence proved. Hence proved. Hence proved. Next, 0. 9.4.1. 9.4.1. Do this homework. 9.5.3. 9.5.3 also. Now we'll discuss Ascoli's theorem. Before going to Ascoli's theorem, we need to study the definition. Definition. What is the definition? Equicontinuous. Page number 85. Page number 85 of your 80. Let A be a subset of. Let A be a subset of. A be a subset of. Script C. XR. Script C XR. What is that meaning? Bounded real continuous function on X, meaning this is script C. This is script C, like that. Script C, XR. Then A is said to be equicontinuous. Then A is said to be equicontinuous. Equicontinuous For each epsilon greater than 0, epsilon greater than, there exists a delta greater than 0. Small delta is greater than 0. Such that, d of x comma y, d of x comma y less than delta, less than delta. That implies, that implies mod f of x minus f of y, f of x minus f of y is less than epsilon, less than epsilon, less than epsilon for all f belongs to A, f belongs to A, for all x comma y belongs to capital X, right? This definition you have to understand. Otherwise, Pascal's theorem cannot understand. What is the definition? Let A be a subset of C x comma R. That means bounded, real, continuous function on X. That means then A is said to be equicontinuous for all epsilon greater than 0. There exists a delta greater than 0. ST means such that d of x comma y less than delta, less than delta. That implies mod f of x minus f of y less than epsilon for all f belongs to A, for all x comma y belongs to capital X. Okay, now theorem, Pascal's theorem, most important. Now,
సార్ సార్
చెప్పండి.
ఇది డెఫినేషన్ లో లెట్ ఏ బి ఏ సబ్సెట్ ఆఫ్ సి ఎక్స్ కామ్ ఆర్ అన్నారు కదా, ఇది బౌండెడ్ రియల్.
C x comma R meaning bounded, real, continuous function on X meaning
ఒక్క నిమిషం సార్. కంటిన్యూస్, బౌండెడ్ రియల్, కంటిన్యూస్ ఫంక్షన్.
bounded, bounded, real, continuous function on X and capital X.
థ్యాంక్ యూ.
Theorem. Theorem. This theorem you need to learn statement also, because sometimes they will ask the state and prove Pascal's theorem. Pascal's theorem. Pascal's theorem. So statement. Prove that. Prove that or show that, like that they will ask. Let X be a compact matrix space. Let X be a, let X be a compact. CPT means compact. MS means matrix space. And A subset of, and A subset of, A subset of script C, X comma R, script C, X comma R, or script C, X comma C. What is X comma C means what? Bounded, complex, real, bounded, complex, continuous function on X, meaning that is real. This is complex. Then A is compact. Then A is CPT means compact. A is compact. If and only if A is closed. If and only if A is closed. A is closed. Bounded and equicontinuous. BDD means bounded and equicontinuous. EQI. CTS means bounded and equicontinuous. Proof. Proof. let A is a compact. Suppose that A is compact, or let A is compact CPT, right? And A is closed. Previous theorems. A is closed. A is closed. Closed. And A is totally bounded. And A is totally BDD means bounded, totally bounded, and hence bounded, and hence bounded, and hence bounded, hence bounded. We shall prove A is equicontinuous, hence bounded. We need to prove that. We need to prove that. Need to prove that. But A is equicontinuous. A is equicontinuous. 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 CTS means continuous. Equicontinuous. Equicontinuous. And hence bounded, and hence BDD means bounded, hence bounded. Let epsilon greater than 0. Let epsilon greater than 0. Let epsilon
సార్ సార్ ఒక చిన్న డౌట్ సార్ సార్
చెప్పండి.
ఇక్కడ 8.4.1 ఏ ఈస్ క్లోజ్డ్ అని ఉంది కదా సార్. ఇప్పుడు ఆ స్టేట్మెంట్ ఒకటి రాయాలా 8.4.1 థీరంది, లేకపోతే మొత్తం ప్రూఫ్ మొత్తం రాయాలా సార్? ఒకవేళ ఇది ఇస్తే ఆర్టికల్ ఇస్తే
8.4.1 అని రాయనవసరం లేదు.
స్టేట్మెంట్ ఒకటి సరిపోద్దా?
బై థీరం 8.4.1 ఉంది కదా, ప్రీవియస్ obtain or we get is closed.
ఒక స్టేట్మెంట్ ఒకటి చాలు. ఓకే సార్.
అందుకోసం నేను రాయలేదు 8.4. అట్లా రాయాలంటే చాలా అవుతుంది. And hence bounded. Let epsilon greater than 0 is given. Let epsilon greater than 0 is given. Since A is totally bounded. Since A is totally bounded. Totally. BDD means bounded. Totally bounded. There exists symbol F1, comma, F2, comma, etc. Fn belongs to A. N belongs to A. Such that ST means such that A equal to union of I equal to 1 to I equal to 1 to N. 1 to N. Yes. Epsilon by 3. F of I. Where yes, epsilon by 3. F of I. That equal to F of I. That equal to F belongs to A, such that D of F comma G less than epsilon by 3. Less than epsilon by 3. epsilon by 3. Since each fi is continuous on x, since each fi is CTS means continuous on x, continuous on x, continuous on x, continuous on x, and x is compact metric space, and x is compact metric space, x is compact, CPT means compact, MS means metric, compact metric space. It follows that Fi is uniformly continuous. It follows that it follows that it follows that each Fi each Fi each Fi is uniformly continuous, is uniformly continuous. CTS means by previous theorems. Therefore, each I there exists delta I greater than 0. Delta I is greater than 0 such that S2 means such that for all x comma y belongs to capital X. This is nothing but definition of equicontinuation. D of x comma y, D of x comma y, right, less than delta I, that implies modulus of nothing but definition only. This is also xi minus f of yi, modulus less than epsilon by 3, 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 epsilon by 3. Now put delta equal to minimum of delta 1 comma, this is small delta 2, etc. delta n, then delta greater than 0, then delta is greater than 0 for all x comma y belongs to capital X, and f belongs to A, First choose I such that we choose I such that f belongs to S epsilon by 3, f of I, that is I means that is supremum, SUP means supremum, small x belongs to capital X, mod f of z, minus f of fi of z, minus d of f comma fi, less than epsilon by 2, less than less than epsilon by 3. Less than epsilon by 3. This is that is number 1.
Excuse sir.
Equation number 2, this is before 1, equation number 1, where epsilon by 3 we don't know. This is equation number 1. This is equation number 2. చెప్పండి మేడం.
ఇక్కడ సపోజ్ f(z) మైనస్ fi(z) ఈక్వల్ ఉంది సార్ టెక్స్ట్ బుక్ లో, మరి మైనస్ ఉంది, పర్వాలేదా? అంటే ఏది కరెక్ట్ అన్నట్టు?
లెస్ దెన్ ఆర్ ఈక్వల్ టు, ఈక్వల్ అన్న లెస్ దెన్ అని చేసి పెట్టుకోవచ్చు. ఈక్వల్ లెస్ దెన్ ఆర్
మైనస్ d(f)(f)(i) రాస్తారు కదా మీరు, ఇక్కడ ఈక్వల్ ఉంది టెక్స్ట్ బుక్ లో.
ఈక్వల్ టు ఈక్వల్ లెస్ ఈక్వల్ టు ఆర్ ఈక్వల్ టు ఏది పెట్టుకున్నా నో ప్రాబ్లం.
ఓకే సార్. ఈ పైన కూడా d(xy) లెస్ దెన్ Δi is equal to f(i)(x) మైనస్ fi(y) ఉంది. మీరేమో f(xi) మైనస్ f(xy) yi అని రాశారు. నో ప్రాబ్లం సార్, ఇలా అయినా ఓకేనా?
ఎఫ్ ఆఫ్ ఐ అంటే ఇక్కడ ఎఫ్ ఆఫ్ ఐ వై
ఇక్కడ fi(x) ఉంది, బట్ మీరు f(xi) అని మెన్షన్ చేశారు.
జెడ్ అని రాసుకోవచ్చు ఇక్కడ, కాకపోతే అది అండర్స్టాండింగ్ అని రాయాలి.
ఓకే, థ్యాంక్ యూ సార్.
ఇది ఓల్డ్ టెక్స్ట్ బుక్
సార్
మిస్టేక్స్ ఉన్నాయండి.
సార్
చెప్పండి.
ఇది సెకండ్ వన్ టెక్స్ట్ బుక్ లో మాకు ఏమని ఇచ్చారంటే సార్, సుప్రీం ఎక్స్ స్మాల్ ఎక్స్ బిలాంగ్స్ టు క్యాపిటల్ ఎక్స్ మాడ్ ఎఫ్ ఆఫ్ జెడ్ మైనస్ ఎఫ్ఐ(z) మాడ్ క్లోజ్ ఈక్వల్ టు డి ఆఫ్ ఎఫ్ కామా ఎఫ్ఐ అని ఇచ్చారు సార్. మీరు అక్కడ మైనస్ రాశారు కదా, అది మేడం గారు అనేది.
కరెక్టే, ఇది మైనస్ కదా, ఈక్వల్ టు ఈక్వల్
అదే డికి బిఫోర్ ఉంది కదా, డి అది. ఇదేమో లెస్ దెన్ మెన్షన్ చేశారు అక్కడ మాకు, లెస్ దెన్ (epsilon/3). అదే సార్ ఇందాక మేడం గారు కూడా అడిగారు.
ఎస్ సార్, అదే.
నెక్స్ట్
ఓకే సార్, థ్యాంక్ యూ.
డి ఆఫ్ ఎక్స్ కామా వై, డి ఆఫ్ ఎక్స్ కామా వై less than delta, that implies or equal, you can read mod plus or you can write equal to also f of x minus f of y, f of y f is less than or equal to mod f of x minus f of I y, f of I x is less than or equal to I x plus f I x plus mod f I x minus f I y. That means where I equal to 1 to n, meaning that is plus f of mod f of I y minus f of y. That means less than (epsilon/3) plus (epsilon/3) plus (epsilon/3) is nothing but that equal to epsilon. We can write less than epsilon also, right, from 1 and 2 respectively. From equation number 1 and 2 respectively. Therefore, d of x comma y, less than delta, that implies mod f of x mod f of x minus f of y is less than epsilon. So for all f belongs to capital A. And x comma definition nothing but x comma y belongs to capital X. So conversely, suppose that A is closed. Suppose that A is closed. A is closed. Bounded and equicontinuous. BDD means bounded and equicontinuous. EQI, CTS, equicontinuous. Since script C, x comma r is complete and A is closed. A is closed. Is complete and A is closed. Since A is closed in script C, x comma r. To prove that A is compact. To prove that A is CPT means compact. It is enough to prove that A is totally bounded. We shall prove that there exists a compact subspace of Y of R such that A is subset are equal to Cx comma Y. Since A is bounded. A is bounded. There exists K1 greater than 0. Such that df comma g is less than or equal to K1 for all f comma g belongs to A, f comma g belongs to A. Choose f naught belongs to A. Since f naught is continuous on the complex space X. Since f naught is continuous, CTS continuous on the compact space. Space X. So f naught X is bounded subspace of is bounded. BDD means bounded subset of R, capital R, means set are real, and hence there exists here. And hence there exists a K2 greater than 0. K2 greater than 0, such that mod f naught x mod f naught x is less than or equal to K2, for all small x belongs to capital X. This is considered equation number 4. Before one, this is equation number 3, right? Equation number 4. Put k equal to k1 plus k2, k1 plus k2, k1 plus k2. Then by any, then f belongs to capital A, and small x belongs to capital X. Modulus of mod f of x less than or equal to mod f of x minus f naught x minus f naught x plus modulus of f naught x. What we did here, f naught x added and subtraction we did. That means is less than or equal to k1 plus k2. From above we get k r by 3 and 4 by third equation and fourth equation. Third and fourth, right? Put y equal to minus k comma k. Then y is compact. F of x belongs to capital Y. X belongs to capital Y. For all f belongs to A. And small x belongs to capital X. Thus, we have A is subset or equal to C x comma y. Now we shall take proving that A is totally bounded, that epsilon greater than 0 is given, and A is equicontinuous. There exists a delta such that is also already all given. D of x comma y less than delta. That implies mod f of x minus f of y less than epsilon by 4 for all f belongs to capital A. There. And for any x comma y, for any for all x comma y, for all x comma y belongs to capital X. Capital X. Since X is compact, there exists a, since X is compact, X is CPT means compact, there exist x1 comma, x2 comma, etc. xn belongs to capital X, such that ST means such that capital X equal to union of I equal to 1 to n, union of I equal to 1 to n, S delta xi, S delta xi, S delta xi. Put ui equal to, put ui equal to, S delta xi, S delta xi, S delta x. Then mod f of x minus f of xi, f of xi less than epsilon by 2, less than epsilon by 3 for all x belongs to ui, x belongs to ui, and f belongs to a, and f belongs to a, and f belongs to a, f belongs to a. So this is the equation number 5. Equation number 5. Since dx comma less than delta for all x belongs to ui, also since y is compact, there exists a, since y is compact, there exists y1 comma y2 comma etc. yn belongs to capital Y, such that capital Y equal to capital Y. Union of j equal to 1 to n, n2 equal to n. Yes, epsilon by 8, epsilon by 8, y of j, y of j, y of j. Put here, put vj, v suffix j equal to s epsilon by 8, s epsilon by 8, y of j, y of j. So then the diameter of vj is less than or equal to epsilon by 2. Then the diameter of v suffix j, v dash suffix j is less than or equal to epsilon by 4. Epsilon by 4. Let I equal to, let I be the set of functions of alpha let I be the set of let I be the set of all functions of alpha from 1 to n, from 1 comma 2 comma 1 to n, 1 to n into 1 to m, 1 to m for any alpha belongs to, for all alpha belongs to I, alpha belongs to I. There exists F belongs to A. F belongs such that Fxi 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 belongs to V alpha I V alpha I V alpha I. Choose one such function and call it F alpha. Choose F alpha. F alpha. The collection of F alpha is indexed by A. The collection of F alpha is indexed by a subset of I. Is indexed by subset of alpha dash, subset of I dash, and I of I, hence finite of I, hence finite, Now shall prove that open spheres S epsilon F of alpha, S epsilon F of alpha, S epsilon F of alpha for all x belongs to capital X, open spheres cover A, F of alpha cover A. Cover A. That alpha belongs to A for I lies between 1 and 2. Let F belongs to A by definition. So I is lies between 1 less than or equal to I less than or equal to N. Choose alpha I. Choose alpha I. Alpha I belongs to 1, 2, etc. M. 1, 2, M. Such that Fxi F of xi belongs to V of alpha I, where I lies between 1 and N. For alpha belongs to I, we shall prove that F belongs to S epsilon F of alpha for all x belongs to capital X. Choose I such that I belongs to capital U. Then mod f of x minus f of xi less than epsilon by 4 by equation number 5. Then modulus of f of xi minus f of alpha x less than epsilon by 4. Since fi xi r belongs to V of alpha j. So modulus of f alpha xi minus f of alpha x less than epsilon by 4 less than epsilon by 4 by 5. Reason. What is the reason here? For all xi comma f of alpha xi belongs to v of alpha i for I. That is the reason, question. So from we get modulus of f of xi minus f of alpha xi equal to less than 3 by 4 epsilon 3 by 4 epsilon by 5 3 by 4 by 5 now 3 by 4 epsilon for all x belongs to capital X and hence and hence and hence and hence d f comma fn f comma f alpha that equal to sup means supremum of small x belongs to capital X modulus of f of x modulus of f of x minus f of alpha x f of alpha x f of alpha x less than or equal to 3 by 4 3 by 4 epsilon that is less than epsilon. 1 is less than 3 by 4 no? Like so therefore f belongs to s epsilon f belongs to s epsilon f of n therefore Sn S epsilon comma Fn S epsilon Fn. That means alpha belongs to I, where I is the indexed function. Covers A. So then A is totally bounded. Then A is totally bounded. Already. Then we proved A is complete. We have proved that A is complete. We proved A is complete. A is complete by previous theorem. And A is compact. And A is CPT, means compact. Same proof is valid. Same proof is. This is we did the proof for real bounded continuous real valued functions we did. The same proof is valid. The same proof. The same proof valid for valid for script C, x comma C means what is that meaning? Bounded complex real bounded complex valued functions, continuous functions, right? This completes the proof, hence proved. Hence proved. Today I thought I need to finish one more chapter also, but its time is not enough. Okay. Then this theorem is most important for most important. Okay. Thank you very much. I'm writing on the web. I'm writing Wacom tab. I'm writing tab. Are you able to see this now? All of you? Hello? Anybody seeing now? I'm writing a webcam. హలో
హలో సార్, ఇప్పుడు మీరు రాసింది కొద్దిగా అంతా ఏమన్నా ఉంటే పీడిఎఫ్ పంపించాలి సార్.
అదే నేను రాసి కనబడుతుందా?
వినపడుతుంది సార్.
కనబడుతుందా? నేను రాసింది వెబ్ క్యామ్ లో రాస్తా. వాకమ్ ట్యాబ్ అని ట్యాబ్ మీద రాస్తున్నా, మీకు కనబడుతుందా అంటున్నా.
అంటే అవపడుతుంది కదా సార్, కొంచెం చిన్నగా అవపడుతుంది.
ఎందుకంటే ఇంకొక ఇది పెంచుతాను నెక్స్ట్ క్లాస్ కి ఇది పెంచాలేమో. ఇది 125 ఉంది, 200 చేయాలా? 200 ఉంది లాస్ట్. 200
200 చేయండి సార్. 200 చేస్తే కొద్దిగా
అట్లా రాస్తాను. చెప్పింది ఈ ఆస్కాలస్ థీరం మాత్రం కంపల్సరీ క్వశ్చన్. దీన్ని ఎట్లాగో స్టేట్ అండ్ ప్రూవ్ ఆస్కాలస్ థీరం అంటాడు.
ఓకే.
అప్పుడు స్టేట్మెంట్ కూడా మీరు నేర్చుకోవాలి. లేకపోతే ప్రూవ్ దట్ అని కన్ఫ్యూజ్ చేయడానికి స్టేట్మెంట్ ఇస్తాడు. స్టేట్మెంట్ ఇచ్చిన ఆస్కాలస్ థీరం అని ఫైండ్ అవుట్ చేయాలి. ఓకేనా? ఐఎమ్ లీవింగ్. థ్యాంక్ యూ.
నెక్స్ట్ క్లాసా సార్? మరి నెక్స్ట్ సాటర్డేనా సార్?
నెక్స్ట్
బియ్యం తెచ్చింది ఇప్పుడు